So, what is Python? Simply put, Python is a programming language. It was initially developed by Guido van Rossum in the late 1980s in the Netherlands. Guido continues to be actively involved in guiding the development and evolution of the language, so much so that he's been given the title Benevolent Dictator for Life, or more commonly BDFL. Python is developed as an open source project and is free to download and use as you wish. The nonprofit Python Software Foundation manages Python's intellectual property and plays a strong role in promoting the language, and in some cases, funding its development. On a technical level, Python is a strongly typed language, in the sense that every object in the language has a definite type and there's generally no way to circumvent that type. At the same time, Python is dynamically typed, meaning that there's no type checking of your code prior to running it. This is in contrast to statically typed languages like C++ or Java, where a compiler does a lot of type checking for you, rejecting programs which misuse objects. Ultimately, the best description of the Python type system is that it uses duck typing, where an object's suitability for a context is only determined at runtime. We'll cover this in more detail in Module 8. Python is a general-purpose programming language. It's not intended for use in any particular domain or environment, but instead can be fruitfully used in a wide variety of tasks. There are, of course, some areas where it's less suitable than others, for example, in extremely time-sensitive or memory-constrained environments. But for the most part, Python is as flexible and adaptable as many modern languages, and more so than most. Python is an interpreted language. This is a bit of a misstatement, technically, because Python is normally compiled into a form of bytecode before it's executed. However, this compilation happens invisibly, and the experience of using Python is one of immediately executing code without a noticeable compilation phase. This lack of an interruption between editing and running is one of the great joys of working with Python. What we see here is the development of a simple Hello World program that goes from being a very simple print statement to being a function that takes a parameter, to being a function that takes a parameter that's drawn from the command line. The syntax of Python is designed to be clear, readable, and expressive. Unlike many popular languages, Python uses whitespace to delimit code blocks, and in the process does away with reams of unnecessary parentheses while enforcing a universal layout. This means that all Python looks alike in important ways, and you can learn to read Python very quickly. At the same time, Python's expressive syntax means that you get a lot of meaning into a single line of code. This expressive, highly readable code means that Python maintenance is relatively easy. What we're watching here is the development of a simple word counting function. As you can see, the function is easy to read even if you don't know the specifics of Python's syntax. There are multiple implementations of the Python language. The original, and still by far the most common implementation, is written in C. This version is commonly referred to as CPython. When someone talks about running Python, it's normally safe to assume that they are talking about CPython, and this is the implementation that we'll be using for this course. Other implementations of Python include Jython, which is written to target the Java virtual machine, IronPython, which targets the .NET runtime, and PyPy, which is written in a specialized subset of Python called RPython. These implementations generally trail behind CPython, which is considered to be the standard for the language. Much of what you will learn in this course will apply to all of these implementations. There are two important versions of the Python language in common use right now, Python 2 and Python 3. These two versions represent changes in some key elements of the language, and code written for one will not generally work for the other unless you take special precautions. Python 2 is older and more well established than Python 3, but Python 3 addresses some known shortcomings in the older version. Python 3 is the definite future of Python, and you should use it if at all possible. While there are some critical differences between Python 2 and 3, most of the fundamentals of the two versions are the same. If you learn one, most of what you know transfers cleanly to the other. In this course, we'll be teaching Python 3, but we'll point out important differences between the versions when necessary.